34, the integral from 2 to infinity dx over x cubed minus 1. You might be able to directly evaluate this actually, but I decided to do a comparison test. Here you have to be careful. If you're using a direct comparison test, I feel like I have to always say this now in these videos, direct comparison test, you cannot compare with 1 over x cubed because our function is actually bigger than 1 over x cubed. Okay, we're subtracting by 1 in the denominator, so that's what makes it bigger. Okay, so that comparison would not work and you might get docked. You probably would, to be honest. Instead, let's just use this comparison. 1 over x cubed minus 1 is less than or equal to 1 over x squared, where x squared equal to 2. Something squared is not as big as something cubed. Who cares about this minus 1? As x keeps getting bigger as we approach infinity, x cubed is much bigger, much bigger than x squared. So we're going to be dividing by much more over here on the left-hand side, so the final value is much smaller, actually, okay? So this is an easy comparison now, still. Integral from 2 to infinity, dx over x squared converges, because this power is greater than 1. Or you can just directly evaluate this. It's not bad at all, just power rule. So by comparison test, since this guy converges, our guy is even smaller, so our guy will converge as well. Once again, I want to emphasize, you cannot compare with 1 over x cubed in this direct comparison test because our function is bigger. So how can you argue that something, if we know that 1 over x cubed converges and our guy is even bigger, how can you be 100% sure that something bigger will converge as well? You cannot be. That's the idea of the comparison test. So you have to pick something smaller. And that's what I did over here.